Law of signs.
You said that I'm the one that draws the sign. And she didn't.
Look like an angel. Satan. He was an angel once. Law of signs starts off with scalene triangle. Remember what a scalene triangle is?
We spelled scaling wrong.
Side. That's what it is.
Forgot the E. You forgot the E.
Where at the end?
Yeah.
I don't know how to spell it.
You know what scalene is.
Long time ago.
Now we know where Sam gets her root spelling from.
Me. So if you have a scalene triangle, we can still find out some information using trigonometry, but it's not going to be right triangle trigonometry, so you have to be a little cautious. So scalene means all the sides are totally different, there's nothing fancy going on, and there's no right angles in this. The first thing we're going to do is label the sides, or angles, I'm sorry, or the vertices, A, B, and C. So we have some kind of reference. When you label a triangle this way, this is angle A or vertex A. Opposite is always going to be little a. So the side is considered little a. It's just something you have to get used to for this section. If this is vertex B or angle B, the opposite side is little b. And then obviously little c down here.
Little D.
Remember geometry? Geometry's coming back.
I love geometry.
Angle sides.
So one of the things we're going to do is we're going to drop a altitude in here.
I missed altitudes.
That at least gives us a right triangle. Actually, two of them, which is nice.
Oh yeah, it's so nice.
Yeah, it is. And we'll call this side H.
Why?
Hey.
Sure.
Yeah.
Why not?
So two things I want to look at. The sine of angle A is equal to.
Sine of A is equal to H over B.
H over B.
HBO.
Definitely not that.
Oh,
And the sine of B is equal to.
You guys go backwards.
It's going to be 8.
Sine of B would be H over A.
H over A. Now, both of these equations have only one variable in common, which is
H is
H. Solve both of them for H. And you get H is equal to B sine of A. And this one will have H is equal to
A sine of B?
A sine of B.
You're a genius.
Which sine of B?
Oops. Sine of big B. Now, if you're dealing with systems of equations and you end up, we did this earlier, if they end up both equaling one variable, we can set them equal to
Both
The other.
same
each
thing.
other.
Yeah.
So this becomes B sine of A is equal to A sine of B.
And you're about to prove that.
What is it called when you have two variables equal to the product of another two variables?
Wait, hold up. What?
When you have two variables,
Wait,
their product is equal to the product of two other variables.
Wait, it's a property, I know.
Well, it's not a property, well, it's a setup. It's a name. Begins with a P.
Proportion.
Proportional. These are proportional.
What are you, a parrot?
That would be Sam.
Proportionals are not usually set up as their product language. They're usually set up as their fraction language. Water fountain's right out there. So if I want to set this up as a fraction, I can divide both sides by A and divide both sides by B. So this becomes sine of A over A, sine of big A over little a is equal to sine of big B over little b. We can do the same argument, rotate the triangle so we get C involved in it, and what will happen is you'll get sine of A over A is equal to sine of C over little c. So they're all equal to each other. But generally when you use this law, you just use this side of it. But technically they're all equal to each other. So the sine of the opposite angle is equal to, the sine of the opposite angle over its side is equal to the same setup on another angle.
Oh, wait, what?
A is over here. The side that goes under it is over here. Opposite it.
I have a question. How does it work for, I'm sure that I learned it in geometry, that was like 2 years ago. How does it work for C? Because when you do C, it's not the whole side.
If I rotate the triangle or even just change the letters around, it really doesn't matter. If you make the triangle tall,
But you're still not using the same H.
hold on, rotate it. This is A. This is now B. Here's C.
But you're not using the same H.
It doesn't matter, because watch, you drop the altitude. Let's say this is the altitude, right? Call it
And
H.
it's H, but it's not the same H.
It doesn't matter. Watch. This side is A, this side is B, this side is C, right? So what's the sign of B equal to?
H.
Oh, let's call it capital H for this one. It's capital H over
C.
C. What's sign of C equal to?
I get that.
I know, but
You should show me.
just watch.
Okay.
Capital H over
B.
B. If you solve both of them for H, you're going to get C sine of B is equal to B sine of C. So the H's don't even matter. And then this proportion will look really similar to this one, and transitive property kicks in. So how do we use this? There's two cases that, well, there's three cases. Case one. What are the ways that you can prove one triangle, two,
Use ass.
or none? Be
Ew.
careful when you use it.
What?
Smack them upside the head, would you? Wait. So, case one is angle,
Kill my brain cells
angle,
like that.
side. I know.
I mean, she whopped me.
Did
It
she?
was like a
Good.
freaking vicious.
Which one?
Your daughter.
Good.
I gotta lock her up.
You try.
Rock, you go
I
here.
heard him.
I ain't
She's
going anywhere.
really strong. Like,
Tom Hanks here.
too strong for her good. I really am.
Tom
trying to him.
Hanks. Tom Hanks.
Thanks.
That's what you said. I don't get that.
He actually started. So is this for solving what?
Triangles.
No, solving their proportionality?
No, for
We're
solving their
solving their
sides and
signs.
the angles.
Law
Brain
signs.
cells lost. I'll be patient. Ready?
Hold on.
Doors right there.
Done. Oh, what? Ready.
Apologize, maybe. What? Fun? Games? Don't worry about it. Can I teach now? Maybe? It's amazing how loud you guys can get when I'm trying to teach. Alright, these problems will always give you information. You just have to figure out which one you're going to use with it.
Are we still using that triangle?
It doesn't matter. It's just a generalized triangle. So when you draw your picture, just draw a scalene triangle. Hardest thing to draw unless you don't draw really good right triangles. Most people when they draw these, they draw right triangles because that's what you're used to. So try drawing a scalene. Sometimes you might want to just draw an obtuse one because a lot of people don't understand that some of these angles are going to be bigger than 90, and they're the ones that get tricky. So just label your triangle vertices, label your triangle sides, make sure you get them in the right order because that's the way my questions are going to come at you. So this one says side A is equal to 12 centimeters, so that's a given side. Angle A is 38 degrees, and angle B is 72 degrees. The setup on these is not that hard, it's actually kind of easy. But there is a little flexibility in the formula. You could leave it as sine A over A, or you can take both sides and flip them. Now it depends. If it's sine A and sine B in the top, you really want to solve for the angle. If you want to solve for the side, I highly suggest you put the little a and the little b at the top.
Just subtract 180 to get to C.
We could. I mean, that's a possibility. We can find C real easy. That's not the problem. It's the other side.
Okay.
So
Yeah.
if you leave it like this, sine A on the top, then you're looking for an angle. That makes it easier to find an angle. But if you flip both sides and you put the little a in the top, that's easier to work with finding the side. So what are we finding?
Side B and C.
Side. So I highly suggest you do the flip of it. So what side are we looking for? Which one can we find first?
Sine B.
B. The angle that we have here is the 72. The side opposite is the unknown. So we're looking for little b. So the best way to set it up is little b over the angle opposite. And then, what else?
You said they're all equal, so why don't you just say
They're not
A up-
equal.
Say A up there.
Equals
Put a up there. So
A.
this is 12 over, and its opposite angle is
sine 38.
sine of 38. So this always works on side to opposite angle or angle to opposite side. All right, and then solve. Easy.
Cross-multiply, right?
Cross multiply. Well, you could either A, cross multiply, but you're solving for B, just multiply both sides by sine of 72. So this becomes 12 sine of 72 over sine of 38. And you just type it in your calculator.
Now, this has to be in degree. I'm
Oh
assuming.
yeah, this has to be a difference. Now since you're typing it in the calculator, this is an approximation. So don't put equals, put little squiggly lines.
Are you gonna take off points if we have equals?
But technically you're supposed to put squiggly lines. Because it's not really equal to.
It's
10
18.
point.
What?
Wait,
I
what?
got 18.
I got
18.5.
She's in
And
radio.
which would you like? How far would you want us around it?
18.5 should be fine.
Okay.
If you're looking for an angle, one decimal should still be fine. So this is centimeters. All right, so B is about 18.5. It's not perfect, but it's pretty close. All right, what's that leave?
C.
C. Finding the other angle is not a big deal. Add these two together, subtract from 180. I'm not worried about that. So how would you find C? Could you use quadratic formula? Not quadratic formula. I think it was a Pythagorean theorem.
No.
No. It's not a right triangle, so don't try a squared plus b squared equals c
Why
squared.
don't you find C's angle and then use
All right. Now we need to find C's angle. What's C's angle?
C's angle is
38 plus 72.
It's gonna be
minus
70.
180.
70.
70.
Yeah.
So C is 70 degrees. So we can set this up as little c over sine of 70 is equal to. Now do not choose B because B
Because
is an
You
approximation.
may not, and you may
Let's
not
use
know
A.
if that's right or not.
We had that too. So always go back to something you know, which is that 12 centimeters. So this
All right.
becomes 12 over
Sorry.
sine of 38.
This stuff I can do.
Yeah, this stuff's not that bad. Most people do pretty good at this. So C is equal to
Right?
12 sine of 70 divided by sine of 38. It's on the other page.
Why do you multiply the 12 and 7 together?
Because when you solve for C, you're going to multiply by the denominator.
I got it.
Yeah, but I thought it would be
18.3.
like 12 divided by sine of 38,
Two.
then multiply all by sine.
Order of operations, left to right. It's multiplication and division, so it doesn't matter.
I got 18.3.
18.3.
Where?
Is that what I got? Yep, 18.3. So this
That's approximation
little
too.
c. Little c is approximately 18.3 centimeters. We now have found everything out about this triangle. We have all three sides, all three angles, and we can do a lot of other stuff with it, find its area and all that fun things.
So about angle and cosine.
That one's easy, angle, angle, side.
Just find two angles and you go.
Ah. Case 2. Oops.
CSI over here.
No CSI.
Right? That's what I've been doing part of.
Case 2 is angle, side, angle.
ASA.
NASA, yeah.
Oh, I didn't say NASA.
I know what you said.
That's
Jeez.
what
So-
it spells.
For example, let's find A and C where B is equal to 40 inches, angle A is equal to 77 degrees, angle C is equal to 101. The pictures are only important to get things straight in your head, which goes with which piece. So just a generalized picture, it doesn't have to be perfect, but if you want to be somewhat perfect, 101 is greater than 90 degrees, so you have to draw an obtuse triangle. So call this side C, or vertex C. It doesn't matter about the other two. Little a, little b, little c.
Better draw like yours. This is,
Doesn't have to be, but
I'll just draw all the same way.
on my test, they're all drawn this way. I draw them for you. I don't draw them this way. All right, so B, that's down here. This is 40 inches. Bless you.
Thank you.
And this is 77 degrees. Even though the picture, it doesn't look like 77 degrees, that's irrelevant. Doesn't even matter. C is 101 degrees over here. What can I find first?
B's
Find
gonna
your
be
angle.
the big degrees.
Go find your angle.
Find my big angle.
2
So
degrees.
this one is
B is 1.
1.
No. 2. I'm
2
sorry.
degrees.
2.
Wrong with this?
2 degrees.
2 degrees. Okay, so here's a little hint. If this is 2 degrees and this side is 40 inches, that's the smallest angle, therefore this must be the...
Smallest.
These two sides are going to be huge. Absolutely huge. So, what can we set up? What can we find first?
Get your
A.
A's.
A or...
B or A or C. You can
Or
do
C, it
either
doesn't
one.
matter. So A over sine of A
It's 77. Sine 77.
is equal to B over sine of B.
40. Oh.
Because that's B.
Yeah, sure.
That's B. We'll substitute. Alright, solving for A is easy. So you get A is equal to
Hold on.
40 sine 77 over sine of a lousy 2 degrees. Now the sine of 2 degrees is really, really small. 1,000,
116.8
and this is feet.
inches.
Sir.
Inches.
I'm gonna say centimeter.
So this would be A. Oh,
Approximate.
approximately 1,160. Divide that by 12.
No. Why?
This is the
Change the feet.
93.
93
The other
feet.
one's
Yeah,
not.
that's pretty big. Alright, what other side can I find?
You can find your C.
Find C, so you go C over sine of 101 is equal to
You should
Do
do
your,
the
your
A.
exact. Your
Or
B's.
B.
Your B
Sorry.
is exact.
the exact one is 40 over sine of
2.
2. C2.
and then of course that would be 40 sine of 101 over sine of 2.
1,125.1.
1,000
125.1.
inches. And this is C, approximately. Approximately.
Is that 20 or 28?
25.
Oh, okay.
How does that look like a zero?
It did.
It would have without my
Ah.
glasses.
Stay over there.
So those are actually the two
I
easy
am.
cases for law of
Over
sides.
here and sitting.
The rest of the class is on case 3.
That's it?
What?
What's that one?
This is just case 2, angle side.
No,
angle
which
side.
one's 3?
Oh, case 3?
Side,
Case
side, side.
3.
Angle
Oh,
side
angle
side.
side, side.
Yeah.
Wait, what? Oh, right, you
That's-
said that we could do that one.
Since it spells a bad word, it's not one that guarantees you a triangle because it doesn't prove
Then
congruence.
why are we?
But it still gives us information. We can still find out something about it. This one gives you something called, what's it called?
The same.
When you say something, and it could, ambiguous. This gives you an
Oh.
ambiguous.
What is ambiguous?
It's not certain and it can be almost anything. It can go
I'm
one way or
sorry,
another.
you're mumbling. What?
She's
It
mumbling.
can be either one way or another. It's not very certain.
0 triangles, 1 triangle,
Yeah.
2 triangles. This thing will give us a different possibilities for different information. So depending on what we're given, the way I think of it is we have this infinite side. So if we do angle side side, we're guaranteed that this angle is fixed, this side is fixed, and we have this third side that's on a hinge. It swings. Because I don't know what's going to fix that side. There's no angle forcing this one to be in a specific location. So if the side, this last side is this long, is it going to form a triangle? No, it's going to be dangling in the wind, and we get the 0 triangles case. if that side is just long enough, it's hard to draw this way, but if it comes straight down and hits it, it doesn't have to be at a right angle. It's just in this case it looks like it is. But there are other possibilities where there's only one side on this. And if that's the length of the side right here, and it hits the third side only at one place, how many triangles do you get?
One.
So just one. If I make this side a little bit longer, like here,
It hits
how many times is it going to hit? Well, if you swing it this way, it's going to hit here.
And
And
then
if you
have to
swing it back the other way, it'll hit someplace like over here. You get a triangle out of that mess, but it's not very pretty. So that one would give us 2 triangles.
There are more.
So if that thing swings and hits the line twice, we'll get 2 different triangles out of it. Unless it lands right on top of that line. But that's very rare.
I don't know what you're talking about.
I'm so lost.
Hmm? It's just what happens. If you're given too short of a line, you'll have 0 triangles. If you're given the exact right length of line, you'll get 1 triangle. If it's too long, you technically get 2 triangles out of it. Okay. So let's look at the cases. Do I have 1 triangle? I'm not sure. Where's my angle side? This one is, I think this might have 2. So for example, find angle A and side C when A is equal to 7 centimeters, B is equal to 9.8 centimeters, angle B is 72 degrees.
Wouldn't that be a big C? It's a side C.
Sides are little letters.
Oh,
Angles
right.
are big letters.
Yeah.
Side, little c. That's why I wrote side in front of it. Oh.
Good catch.
So when we draw our picture, I'll put it up here. Doesn't really matter what it looks like.
You just want to draw.
Here's A, here's B, here's C, little a, little b, little c. Put your given information in. A is 7. B is 9.8. We don't know C. Angle B is 72 degrees. Alright, so what do we try to set up? Well, this one, we're given 2 of the sides unlike the other 2. Those 2 were just given 1 side and 2 angles. So our setup is going to be flipped. I want the signs in the top this time because we're more than likely going to be looking for an angle. What angle can we find first? Well, 72 is across from the 9.8. And 7 is across from A. So we need to go looking for A first. So, sine of A in the top.
Yeah.
Little a in the bottom, 7. Sine of, what is it, B? In this case, 72. And B in the bottom, 9.8. Now, when you solve for A, you have to get rid of the sign. So eventually, sine inverse. So we get sine of A is equal to 7 sine of 72 degrees over 9.8. Okay. That's all right. How do you get rid of the sign? Sine inverse. So in your calculator, to get to A, you'll have to get sine inverse in there. Please do not use the reciprocal function. Sine of sine, I'm sorry, 7 of sine of 72 over 9.8.
Sweet.
So angle A, measure of angle A, is
40,
approximately
40, do you want to, what do you want to start with?
1 decimal 1.
Why did you sine of A? Did you use
42.
7 and not 9.8?
Yeah.
When you're solving for sine of A, you're multiplying both sides by 7.
Huh?
When
No,
you're
why did you use 7? I thought it was going to be 9.8 if you drop the thing that makes it into 2 right triangles.
What?
I'm just using the triangle. I'm not dropping it.
But you can't. I thought you couldn't use sine, cosine, and stuff if it wasn't a right triangle.
Well, that's what we've been doing all along.
But did you change that to a right triangle?
No. I didn't change that one into a
No.
right triangle either.
Sam,
It's just a formula.
I don't like it.
we've been doing it the entire time.
I know,
I've
this is
been-
the third
I've been
example,
doing-
and now
I've
you're
been
saying
doing-
it.
I've been doing it for.
Oh, the other way? No, don't do that. So
What's
what's
the other
this equal to?
42.3.
42.3?
Yeah.
8.
42.8.
8.
Never mind. This is in degrees, so make sure you give it its measurement. Now here's the problem with the sine function. When you're dealing with the sine function, sine is positive. What quadrants is sine positive?
1 and 2.
First.
1 and 2.
and
Yeah.
second.
So if its angle is in the first quadrant, it would be 42.8.
Yeah.
But remember that the
Plus
sine
90.
inverse only works in the first and the fourth. It is absolutely possible that this angle is in the second quadrant. And if this angle is in the second quadrant,
Minus 180 minus.
it would be this angle, and this reference angle would be 42.8. So what's 180 minus 42.8?
It's 65.2.
65.2?
Sure.
So there's another possible angle that this could be because we used a sine inverse.
Oh.
And sine inverse only gives us one of the possible answers.
No.
What?
42.8 minus plus 65.2 does not come out to
Yeah,
180.
what's going on?
Wait,
What's
that?
180 minus 42.8?
42.8
Oh,
minus.
I didn't. Did you put
One-
Yeah, I did.
137.2.
I did, I'm sorry.
137.2 degrees. Okay.
What did you do?
Don't ask.
Hey, Sam.
It's just Sam math. So it's possible that the sine inverse gave us the right answer, but it's
Right.
also possible that it could have been the one in the quadrant it doesn't work in, the
So do you- we need to
137.2.
put
Get to the two triangle.
Yeah, this one has two triangles. So, well, I'm not sure yet. So it's possible that A is 42.8, but it's also possible that angle A is equal to approximately 137.2. How would you be able to tell if it works or not?
You
Well, try it out.
Yeah.
Let's do this one first. If this is angle A and this is angle B, what's angle C?
That's
You gotta add into
Something
it.
less than 180.
That's
So what's 42.8 plus
I did that. It's 65.
72?
It's 114.8.
114.8. Subtract that from 180, so angle C in this case
65.2.
That's where I got the number. By the
is
way.
what is it?
65.2.
55.
65.
65.2.
That's where I got my number.
So angle A, angle C, and angle B actually work in a right triangle. They add up to 180 degrees. Let's try this one.
And that one
If
does not
angle
work.
A is 137.2,
That
and
one
I
does
add
not.
72 to it,
That one does not work.
what does it become?
Because
It
it's
becomes more than
209.
180.
Right, so if I add 72 to this, it's greater than 180, not a triangle. So this one only has one triangle, and this is it.
I like this stuff. I wish this was just all that he teaches.
We had
What,
to find
this?
sides.
Yeah.
You would have been boring.
But it's time to go. I got